Welcome to 1.1 part 2. In this lesson, we'll talk about arc length and sector area. So to start, let's talk about arc length. So you have a circle, you put a given radius down, let's see, like right there. Your arc length is going to be right here. That's going to be arc length. So think of it as like the crust of a pizza. Now in Trig is a pretty handy formula. We use S equals R theta. And what's really cool about this formula is that look how simple it is to use. So let's go ahead and 3D box this in your notes. So 3D box again means very important. So let's just highlight that. Make sure we want to put that in our notes. So first I'll just show you how simple the formula is. We're at S equals R times theta. S is our arc length. So I'll make that note here. R is your radius. And theta is your angle. And that's going to be in radians. So in this formula, let's plug in 2. We'll plug in a quarter. And we get S is equal to 1/2 m, which is the answer for this problem. So pretty straightforward. So if you're wondering why this works, think about regular arc length. So I'll put a little bar here for you. In geometry, you probably learned the arc length formula, which would be 2 pi r, which is the circumference, multiplied x degrees over 360. Now if you do the radian version, so I'll put radian version here, we're going to do 2 pi r times theta over 2 pi. Since 2 pi is 360, and then notice how the 2 pi's cancel out, we're left with r theta. And right there, very nice formula. So that's going to be the proof. So up on the side, like proof. So you're going to try this one. Pause the video, try solve it. Okay, so let's do it. S equals r times theta. S equals 6 times 2. S is equal to 12 feet. We're done. Part 2. Let's find the area of a sector of a circle. So if you think about what we just did, we just found arc length, or the crust of a pizza. What we're going to do now is called sector area. So think of sector area as this, like the area of the slice of a pizza. So I'll make a note. That's what we're talking about in terms of sector area. So in this problem, we have 30 degrees. Now this is what a lot of people want to do. The formula that's printed in every single book is this. A equals 1/2 r squared theta. What people want to do is write A equals 1/2 2 squared times 30 degrees. Now you want to make sure you never do this. So put a big line through this. Never do this. The main problem is right here. That is in degrees. You want to make sure you're in radians. So again, all these formulas we're doing today, you got to be in radians. So I'll show you the work here. The correct work, A equals 1/2 r squared theta. A equals 1/2 r squared. You got to convert 30 degrees. So let me draw a line right here for you. 30 degrees, we're going to convert that times pi over 180. Reduce. That's pi over 6. So you plug that in right there. Pi over 6. Let's fill in for r. R is going to be 2. So now we have A is equal to 1/2 times 4 times pi over 6. That's going to be A is equal to 2 times pi over 6. So A must be pi over 3. And don't forget your units, that's going to be feet squared. and there's sector area. Now for proving this, again, the proof is pretty simple. If you think back to your geometry class, same idea. We're going to start with our area formula, which is pi r squared. Multiply that by x over 360, and that's how you get sector area. But in trigonometry, we have our radian version, and that's going to be pi r squared times theta over 2 pi. Cross out your pi's, you get r squared theta over 2, which is what the formula we had. So to summarize, I'll put that, let's put our notes right over here. So let's grab this thing, let's move it down. We're going to put a equal to 1/2 r squared theta. Let's put a nice box around this. Not working. Let's do the old school way. And again, you want a 3D box set to show that's very important. And put a big note in your notes at this theta right here, radians. Can't miss that. So now you're going to try this problem on your own. Pause the video, work it out. Alright, let's try it. So we're going to write a equals 1/2 r squared theta. Notice how you have the radius given, that's just 6 squared. Theta, we can't just write 2, because notice how it is in radians. So now we have, let's cross those out. A is equal to 36 feet squared, and we are done. So now you can do the rest of the homework, and good luck.